Now let's look at the test student class. In this class, we are going to use the object of student. And look at this another nice feature of BlueJ. It shows the relationship between classes. It's called a simplified UML, the Unified Modeling Language. So from this diagram, we can see test student, this dashed line, then the arrow, use student. That means when student class get modified, you should check your test student. At least you should recompile it, maybe modify your source code as well. So let's take a look at the test student class. In this class, we have a public static void main. That's an entry point of your application. And let's take a detailed look. First of all, of this prototype, the only thing you can change is the args, that name. All the other ones, you cannot change them. So you have to type exactly like that. I'll explain in detail. So public means it's accessible. So the JVM is supposed to invoke this main method for you. So you have to make it public. And static means you don't have to create an instance of test student to invoke this main method. You can just have the class and invoke it. So it's important too. And void, it won't return anything. You have to keep it that way. And main, including the lowercase, so you have to keep it exactly like that. So you can take an array of strings as command line arguments. We will talk more about that. That's just a name, so that doesn't matter. So we create two objects of student class using the default constructor and the constructor that takes in two initial value. The big difference here is this won't compile in C++. In C++, you dynamically allocate two student objects here. You see, we dynamically allocate two student objects. So new student will allocate the student object on the heap and give you back the address, and you're supposed to save it in a pointer to student because it contains the address of a student object. So this line won't even compile. But in Java, we don't talk about a pointer because every object is a pointer. So essentially, S1 contains the address of that newly allocated object. So essentially, it is a pointer, but we just don't say that. So that's one difference. And another difference will be you always allocate objects dynamically in Java. You cannot allocate the objects statically on the stack in Java. Like in C++, you can do that. In C++, when you say student S1, you allocate some objects on the stack. But here, you always do the new thing. You always allocate objects on the heap. So that simplifies stuff. And another difference is you only allocate it and you don't need to delete it. So that's a big relief. Remember, in C++, after we dynamically allocate anything, somewhere we need to deallocate it when we don't need to use it. Otherwise, we got memory leak. It's a big pain to manage your own memory, because especially when we share objects. So you allocate these objects and you reference these objects in multiple places. Then later on, when it's time to delete this object, exactly who's going to delete it, when this object is going to get deallocated, it could be complicated. If you don't delete it, you got a memory leak. If you delete it too early, your program crashed because somebody else is referencing it too. So, but in Java, we don't have this burden. So there's some program called the garbage collector running in the JVM to sweep through the memory and to see, hey, which memory is idle, like nobody is using it. Then it's going to release it back to the system. So that's called garbage collector, and that's very helpful. So you don't need to delete dynamically allocated object, and every object is dynamically allocated. All right, and now let's see those ones. So I do some labeling and say s1.toString. That will convert s1 into string. And remember, we have this inherited method, but we did better. We even override it with some meaningful string representation. And s2 here, this one is identical to this one because even if we don't invoke the toString method, the compiler will invoke it for us. So usually you don't see this toString method there. And then I invoke some set GPA and display it. And here test the equality. The first test is to test the equality using the equality operator. That operator is using the default testing for equality, testing identity, testing memory address. So those ones shouldn't be equal because those are two separate objects. But this one depends on if you override it or not. We override it, so it's going to test the ID for equality. Otherwise, if you don't override it, it's the same behavior as the equality operator. And we invoke the static method. This is how you invoke it. You invoke it through class name instead of instance name. You see the difference here? When we invoke instance method like this, set GPA, we have to say, hey, set GPA of which object? You have to give it the instance, the object first, then set GPA. Otherwise, it doesn't make sense. But get number of students has nothing to do with individual instance. It has something to do with the class. So you use class name to invoke it. So that's the difference between invoking static method and instance method. And now let's see, we use command line arguments. Remember here, we allow user to pass in an array of strings as command line arguments. So when they run this test student, they're going to run it this way: Java test student, and give us an array of strings. And here we're going to demonstrate how to use that array of strings. So you see, I create S3 using the first argument and the second argument. So I assume they're going to give me two IDs. And then I create an array. So this is how you create an array in Java. You say new student, give it the capacity, and we populate the array with S1, S2. We created before, and S3, S4 created from the command line arguments. So that's how we populate the array. Pretty much the same as C++. The only difference is here you create it using the new operator as well. So, and now here's something new. So we have the fancy for loop here. So how to iterate through this for loop? We can do for student as, it's just a temporary variable to loop through the student list, and you do this. You see, it's very elegant syntax. That's something new after Java 1.5. Before that, we don't have it either. So this is new for loop. Use a temporary variable, loop through this list, and just do this. Alright, and now let's see. We want to create a copy. And how do we do array copy? There's something in the library called system.arrayCopy. So I'm going to show you how to look up the API to find out how to use some method. For example, let's look at this one. The system is started with an uppercase S, which means it's a class name, and .arrayCopy with some parameters. That means ArrayCopy is a method. So we can guess ArrayCopy must be a public method of system class, and we know for sure it has to be a static method too, because you invoke it through a class name. So we can look in the API to see how ArrayCopy works. So you can open Google and Google Java API. It will take you to the 1.61, and that one works fine. And you see in the API here, you can click on all classes. When we know more about packages, you can click on individual packages. And here are all the classes. Let's get the system one. So system is the one we are looking up. This is the system one. When you click on system, you see it tells you class system is in a package Java package is a big package. Then there's a sub package called lang, stands for language, and inside that package we have a class called system, and this one tells you which package system is in, and this one tells you the inheritance here. System has a parent class, is an object class. Again, everybody got a parent as an object, and it tells you some introduction about what's a system class for. And we're interested in array copy. So take a look, it's static like how we predicted. It's a static. So this one summarize what array copy does. Remember when I talk about documenting your method, you should use one sentence to summarize what this method does. You see, this is one sentence because all the way to the first period will show up here in the method summary. So it's important to use one sentence to summarize what this method does. So if we want to know the detail, we're going to click on array copy. So here's all the detail about array copy. Let's see. The first one is that you have to tell me the source. The object array is an object too, so and you have to tell me the source array starting from which position, and the destination array and starting from which position, and how many elements you want to copy. You can go through the document in detail when you have time. So now let's see. System.arrayCopy. So we're copying from student list. That's the one we just populated, and we're going to copy from index 1. So we skip the first one. The first one is S1, so S1 shouldn't get copied. And the destination is student list 2, and the starting index will be 0. That means I want to copy it into the first element, and so on. And I want to copy 3 elements. So after the copying, I did that fancy for loop again, and you see, no need to delete the object created. The garbage collector will do that for you. Okay, so let's compile this one and run it. So right click on this one and say main. And remember, we use the command line arguments for the IDs. So I'm going to give it G10 and G20. I don't remember how many we need, but I can give it more. I give it G30. So okay. So when you pass in string, you have to separate them by comma, and to say it's a string later, you have to put it within double quote. So now let's compare the output with the source code. So the toStudent object after changing GPA only show if equals overridden, which is right. The number of student object created so far, and the student list, and a copy of the student list. Alright, thank you.